Hi, I bought an Antec Kuhler 620 or H20 620 CPU sealed all-in-one cooling system. That's the pump from it there. It was sold as faulty and for parts were not working. When I asked the guy, is the pump working, is the fan working, he said the fan's working, but he's tried it on two CPUs and they both overheated, so he doesn't know what's wrong with it. Well, I've noticed that quite a lot of other people have got a same problem with this type of setup, so I thought, well, let me see if I can find out what the problem is, and I believe I found it, and that may be of value to you. What you can see here, I've stuck two wires into the connector, the power connector. These correspond with the power positions. I'll check that out, and I've already tested this, and I'm going to show that in fact the pump itself is not turning when you connect it against a 12-volt battery that I've got here. The little pump just isn't turning. However, if I remove this cover here, which I've already done previously, as you can see, and I do the same thing again. Oh, it's not doing it now, but it was, I promise. When I examine this more closely, it has two little rubber bushes, tiny little things that go on the bearings, and these are actually quite a tight fit in the top and bottom of the rotor here and the pump. Now, it seems to me that the reason this is jamming is because these little bushes are too tight, and that's what's making it stiff, and that's what's basically preventing it from turning. So what I'm going to do is I'm going to gently file down the shafts here, which you may be able to see, a little bit of shaft here and a little bit of shaft here, to see if I can reduce the friction essentially and allow it to turn. So let's see how I get on. Now, I've got quite a fine diamond tipped profiling tool in my Dremel here that I'm going to use on the slowest setting, with the intention of reprofiling both ends of this shaft on the impeller for the water pump. So let's see how I get on. Okay, I've taken off just a tiny bit off the end of the shaft and taken an imperceptible layer off the edge at the end. I don't know what this shaft is, but it's very hard material, and I was using a diamond tipped bit, but the way I've got it now, that's the end, and I've just put the little rubber bush back in the center there. So now this fits in, and it actually rotates quite comfortably in the rubber bush. So that's probably enough for the top half. I'm now going to do the bottom bit. Right, I've actually changed to a much finer bit for doing the bottom, because there's really not a lot of gap around the shaft there. Right, what I've done now, I've done the bottom and put it back in here in the bearing, and this now turns much more easily by hand, and I've connected up to the fan as well. So what you should be able to see is that when I make a reasonable electrical connection here, which isn't that easy, the little rotor rotates with the fan. Obviously it's rough because it's only got bearing on one end at the moment, so that seems to have solved the problem. So let's test it. Well, the battery went yesterday on the camcorder, which is probably just as well because it makes this shorter. So the first problem with this Kuhler 620 was the bearing design, which was clearly not as reliable as it should have been, and it made the rotor too stiff. I fixed that problem, but in fact while I had been testing it originally, both before and after I'd modified the bearing area, I was suspicious that it wasn't always driving the rotor when I thought there should be a good electrical connection. And in fact that's why I connected the fan, so that I could see when there was a good electrical connection, because it should have been driving the rotor as well. What I discovered is that sometimes it just did not seem to be strong enough to drive the rotor, even when it was relatively loose, and so there seems to be some other problem as well as the bearing design. That to me is a bit of a fatal flaw in something that's supposed to be reliable, and that should be compared to, for example, the pump in my fish tank, the filter pump in my fish tank, which is basically a very similar design, except that runs directly off the mains, and that's been running for 10 years non-stop almost. In fact, not non-stop, because it stops every night for a few hours. So it restarts itself easily every single day, and it's been doing that for the last 10 years. So that's not very good of this design. The third element is that I'm not really that keen on the idea of these micro-channel copper blocks. Now I didn't actually show you that inside, but it's got these really narrow channels, so fine you can hardly see them really. I'm not happy about that for two reasons. One is that when you've got very narrow channels, that creates a lot of resistance to the flow of water. And while you do get good transfer of heat to the water, the fact that you're creating quite a significant obstruction to the flow of water means that unless you've got a reasonably powerful pump, you're actually going to slow down the flow of water. So ultimately you may be it may be detrimental to the actual amount of heat transferred. The second thing is that it was already obvious that there was a little bit of blockage occurring on some of the channels because of little bits of debris coming off from what I presume was probably the pump bearings, even though it was a sealed system. And of course, if there is any kind of corrosion at all, then that's going to block the channels almost completely. So not particularly happy about that. What I ended up doing was removing the fan, the rotor completely, so this can be used as just a heat block, and I'm going to get a separate pump to use with it, because the radiator looks pretty good. Also this has got fairly narrow channels, but if it's got a better pump that might not matter. So all in all, I would say, given that so many other people have had problems with heat transfer, I think there are probably several reasons. One is the bearing design, which caused the rotor to become too stiff. The third is it seems to be marginal in terms of the strength required to turn the rotor reliably, and that may fail for electrical reasons possibly. And thirdly, the micro-channel blocks I think is going to inhibit the flow in the long term. So all in all, I think this is probably not a particularly reliable device. So best avoid it, in my view.